Good day, everybody. My name is Arla Diana, and today my group members and I will be presenting our video assignment for Mechanics of Material. So before we start, I would like to explain a little bit about our methodology. We are all applying our knowledge of learning outcomes from LO1 to LO3 into our chosen biomedical device, which is the elbow crutch. It is explained by solving example problems with assumed appropriate dimensions, and calculations will also be shown.
Hello, my name is Ismail, and here we are using the elbow crutches as a real life example. And many people use crutches when they recover from injury or when they have a disability that they provide the stability and balance by shifting the weight of the lower body to the upper body. The crutches have been used since ancient Egypt, when the Egyptian used three crutches to help balance. A pair of crutches must meet three criteria, which are the strength, comfort, and coordination. And the crutches made from aluminum alloys, which is strong and light. The crutches cuff are made of plastic, and the crutches tip is typically made from rubber and to ensure in case to absorb the shock.
Hi, my name is Sudha Kistina and I'll be presenting LO1, which studies action of axial and torsional load. For under action of axial load, we want to calculate the axial stress experienced by the lower shaft of this crutch when 410 Newton is applied. Next, for the action of torsional load, we want to calculate the shearing stress experienced at the shoulder part of the crutch when 18 Newton meter torque is applied by the useries, given the radius of the holder part is 4 cm. For the calculation, as I've mentioned before, we want to calculate the axial stress experienced by the lower shaft when 410 Newton is applied. So this is the free body diagram, given the diameter is 25 mm and the line is 800 mm. The force applied in this direction is 410 Newton. Before calculating this axial stress, we have to find out the area. So by using this formula and after substituting all the values, we get 4.9087 times 10 to the power of negative 4 millimeter squared. So then we can substitute the values into the formula of calculating axial stress, which is force applied divided by area. Then we get 0.8352 megapascal. For shear stress, this is the free body diagram of torque applied, which is 18 Newton meter. So first, before calculating shearing stress, we need to know the polar moment of inertia J. So this is the formula of J, which is 1/2 times by pi and c to the power of 4. So substitute all the values, and c is the radius given by the question, which is 4 cm. Then we get 4.021 micrometer to the power of 4. Then using this formula of shearing stress, we substitute all the values. We get 179.06 kilopascal. That's all from me. Thank you.
Hello, my name is Muhammad Hafiquzuddin and I want to present the LO2, which is solving the problems involving the stress in beams. So for the first problems, we have to determine the normal stress if the average force acting on the arm support is 350 Newton, given the diameter of crutch is 25 millimeter and the thickness is 5 millimeter. So this is the FBD for the system, and also the cross-sectional of the shaft. So we want to find the normal stress, and it can be calculated by the given formula, which is F over A, where F is the average force acting on the arm support and the A is cross-sectional area for the crutches. And before we calculate the normal stress, we must find the area for the cross-sectional. Because this is the holder shaft, we need to find the total area and minus the hollow area. Then after substitute all the values, can get the area is 314.1593 millimeter square. And then we can substitute all the values to the formula and we can find the normal stress for these problems is 1.11 megapascal. So for the next problems is we want to find the maximum shear stress by the hollow shaft of the crutch. If the applied torque is 1 kilonewton meter, given the diameter is 25 millimeter and the thickness is 5 millimeter also. So this is the FPD for the system and also the cross-sectional of the hollow shaft, and we can determine the maximum shear stress by this formula, which is C times C divided by J, where the T is the applied torque, C is the radius, and J is the polar moment of inertia. So before we can calculate the maximum shear stress, we must calculate the polar moment of inertia. We can calculate the polar moment of inertia by this formula, which is pi over 2 times r to the power of 4 minus r small to the power of 4, which is r is the maximum radius and the r small is the radius of the hollow shaft. And then we can substitute all the values and can determine the polar moment of inertia of the hollow shaft, which is 3.3379 times 10 to the power 4. And then we can proceed to insert all the values to the formula. Make sure to change the Newton meter to the Newton millimeter, and then you can determine the maximum shear stress for the problems is 374.49 megapascal.
Hi, I am Hisham. Now, we are going to solve some problems regarding learning outcome 3, which are stress and deformation of biomedical devices due to compound load. We want to calculate the stress and deformation of the hollow shaft of the crush, as we can see in the diagram here, when 370 Newton of force is applied on the crush by the patient. The length of the crush is given 800 mm or 0.8 meter, while the outer and inner diameter of the crush is given 25 mm and 15 mm respectively. The crush is made out of aluminum material with the value of elastic modulus E equals to 69 gigapascal. The first problem we want to solve is regarding the stress exerted on the crush due to compound load. In order to find the stress, we need to calculate the cross-sectional area first. The radius can be determined by dividing the diameter by 2, and we get the outer radius of the shaft denoted by capital R is equal to 12.5 mm, and the inner radius of the shaft denoted by small r is equal to 7.5 mm. The area of the circle can be determined by using the formula A equal to pi r squared. And we can find the cross-sectional area of the hollow crush by using this formula, and the cross-sectional area of the hollow crush is equal to 3.1416 times 10 power of -4 meter squared. Then the stress exerted on the crush due to compound load, which is 370 Newton, can be calculated using the formula of stress below, which is sigma equal to F over A. F is equal to 370 Newton and divided by A, which is the value of area we calculated just now, which is 3.1416 times 10 power of -4 meter squared. And the stress exerted on the crush due to compound load is equal to 1.1777 megapascal. And next, we want to solve the problem regarding deformation. The deformation experienced by the crush can be calculated by using this formula. Delta equals to FL over AE. F is the force exerted on the crush, L is the length of the crutch, A is the area of the crutch we calculated just now, and E is the elastic modulus of the material. We are choosing the aluminum material, so the elastic modulus is equal to 69 gigapascal. And we plug in all the value in this formula and get the deformation experienced by the crutch is equal to 13.655 micrometer. That's all for the on how to solve the problems regarding learning outcome 3, which are stress and deformation of the biomedical devices due to compound load.
In conclusion, our group members together have achieved understanding of all of the learning outcomes shown. So, elbow crutch is an important medical device which helps a lot of people, especially people with leg injuries or lifelong disabilities. So it is important to understand the mechanics of crutches, as it is important to design a safe and a convenient crutch for patients. So by mastering all the calculations, we can invent more convenient elbow crutch in the near future. So that's all from our group. Thank you.